So we want it to be as fast as possible because yesterday we skipped our lecture. So it would be nice for us to finish all the presentations today. Manueri. Jawazandi ndiri parebhora ndoya mangwana katingoti mangwana kana 12 tongoti mangwana na 12 ndoya pandoya chitwa chimfana ndiri parefa anazani pati alright ana isindoya alright thanks. Oh, sorry for that. That is unmuted.
Tachida tunza zama.
Hamna kunzwa makuu wangu.
Tachida tunza zama zini.
Exam, there's nothing new. There won't be any surprises. I tumbotanga twana ma presentations first. And don't worry about the examinations. I've never had students who fail my exam. Once we agree with Python, there's no reason why the exam should be difficult. The exam data good. Because it's a process. But what is important is this practical. Because though contributor. So I might decide to then change if you are you are very good in your presentation, then I can change the coursework mark to 160 for it. So it depends on how you are going to present. Right. Nice. There's Bright. What is your opinion? All right. Order of presentations. There's no order. I think we can start with those who are ready. Those who are ready can present first, can come first. But what is important is for everybody to present today. All right, I'm going to record some. It's okay. So we can start now. Is it?
Yes, I'm going to be sharing my screen. Then Alan will be presenting. Alan, okay. Are you ready?
And how many are you in a group?
We are about 8.
All right. Hey, 8. It's okay.
Good morning, everyone. Am I audible?
Yes, we can hear you.
Okay. We are starting. So we are starting on classification in web mining analytics. Classification is a fundamental technique in web mining analytics that involve categorizing data into predefined classes or categories. It is a function that assigns items in a collection to be specific into categories or classes. It's a supervised learning method where it's a supervised learning method where the algorithm is trained on a labeled data set to learn the pattern and relationships between the features and class labels. For example, if the patients are grouped on the basis of their own non-medical data and treatment outcome, then it is considered as classification. There is a purpose of classification. Purpose of classification in web mining. One, we have predictive modeling, predicting user behavior Classifying user behavior pattern can help in personalized recommendation, targeted advertising, and customer segmentation. Predicting future trends. Analyzing historical data can help predict future trends and patterns in user behavior. Anomaly detection. Anomaly detection, we are saying it identifies outliers. Classification algorithms can identify unusual and anomalous pattern in data, which can be indicative of fraud, security breaches, or system failure. Then we have sentiment analysis, determining opinions. Classification takes data into positive, negative, neutral sentiments can help understand public opinion and customer feedback. Then recommendation system. Classifying users and suggestion items. Classifying users and items based on their attributes can help to recommend relevant products or content. Then customer segmentation, which is grouping users. Classifying customers into different segments based on their characteristics can help tailor marketing campaigns and improve customer satisfaction. Then importance of classification in web mining. Predictive modeling. Predicting user behavior. Classification can help predict user behavior pattern, that is enabling personalized recommendation, targeted advertising, and customer segmentation. Forecasting trends. By analyzing historical data, classification can help predict future trends and patterns in user behavior. Then we have anomaly detection. Identifying outliers. Classification algorithms can identify unusual and anomalous patterns in data, which can be indicative of fraud, security breaches, or system failure. Identifying anomalies. Classification techniques can help detect fraudulent activities by identifying patterns that can deviate from normal behavior. Then, for example, unusual transactions pattern in e-commerce can be flagged for further investigations. Risky management, for example, unusual transaction patterns in e-commerce can be flagged for risky management. By classifying transactions as legitimate or fraudulent, organization can minimize financial losses and protect customers from potential scams. Then we continue on the importance of classification in web mining. We have sentiments analysis, determining opinions. Classification takes data into positive, negative, or neutral sentiments can help understand public opinion, customer feedback, and brand reputation. Recommendation systems, suggestion items. Classifying users and items based on their attributes can help recommend relevant products or content. Personalized experience. Classification is key to building effective recommendation systems. By categorizing products or content based on user preference and past behavior, business can provide personalized suggestions that enhance user experience. Increased engagements. Tailored recommendation based on classification can lead to higher user engagement and conversion rates, as users are more likely to explore content that aligns with their interests. Then another importance, we have customer segmentation, grouping users, classifying customers into different segments based on their characteristics can help tailor marketing campaigns and improve satisfaction. We have marketing and trend analysis, tracking trends by classifying web content. Business can monitor emerging trends in their industry or niche. This helps in making informed decisions about product development and marketing strategy. Competitor analysis. Classification can be also used to analyze competitors' online presence, allowing organizations to identify strengths and weaknesses in their strategies. Resources optimization is another important. Efficient data management. Classification help in managing processing large volumes of web data efficiently. By categorizing data, organizations can prioritize resources and focus on high impact areas. Also have improved decision making. With classified data, decision makers access relevant information quickly, facilitating better and fast decision making process. Then on the classification process, number one, we have data collection. This is the initial stage where raw data is gathered from various web sources. The quality and quantity of the collected data significantly influence the performance of the classification model. On the methods of data collection, we have web scraping, automated tools or script that can extract data from websites. Then APIs, using application programs, interfaces to access data from web services, for example, social media platforms, online databases. User interactions, collecting data from user activities on websites, click, purchase, comment. Public data sets, utilizing existing data sets available for research and analysis, often from academic and government sources. Then considerations. We ensure compliance with legal and ethical standards, for example, data privacy regulations. Aim for a diverse data sets to capture various patterns and features. Number two, we have data pre-processing. Definition. This stage involves cleaning, transforming the collected data to make it suitable for analysis. Proper pre-processing enhance the quality and model performance. The steps of data pre-processing, we have data cleaning, that is removing duplicates, correcting errors, handling misvalues. Technique include imputation, filling in missing data, or detection, removing incomplete records. Normalization or standardization, scaling numerical features to a common range. For example, from 0 to 1, that is to prevent bias in model due to varying scales. Text processing. For textual data, this may involve tokenization, that is breaking text into words, stemming, reducing words to their base form, and removing stop words, like for common words that add title meaning. Coding categories, variables, converting categories data into numerical format using techniques like one-word encoding or labeling encoding. Number three, we have feature selection. Feature selection involves selecting the most relevant features or attributes from the datasets that contributes significantly to the classification task. The techniques filter method use statistical techniques to evaluate the relationship between each feature and the target variables, e.g. chi-square test, correlation coefficient. Then wrapper method use a specific classification algorithm to evaluate the performance of different subsets of features, e.g. recursive feature elimination. Embedded method perform feature selection as part of the model training process, e.g. loss regression, decision tree, feature importance. It reduces dimensionality, leading to faster train times and reduce overfitting. Improve modern interpretability by focusing on significant features. Modern training, that is number 4, it is and in this stage, the selected feature and the selected features and training datasets are used to build the classification model using various algorithms. Then the steps: choosing the algorithm, select an appropriate classification algorithm based on the problem, decision tree, support vector machines or neural networks. Training models, feed the training model to the algorithm, allowing it to learn relationship between features and the target labels. Hyperparameter tuning, adjust the algorithm parameters to optimize performance, e.g. learning rate, number of trees in random forest. Then considerations, use techniques like k-fold cross-validation to ensure more than generalize well to unseen data. Monitor the overfitting, where the model perform well on training but poorly on test data. Number 5, model evaluation. On model evaluation, after training, the model is evaluated using a separate test dataset to assess the performance and predictive accuracy. The metrics, we have accuracy, the proportion of correctly classified instance out of the total instances. Precision, the ratio of true positive predictions to the total predictive positive, indicating the model's ability to avoid false positives. Recall, that is, recall or sensitivity, the ratio of true positive predictions, the total actual positives, measuring the model's ability to identify all relevant instances, that is F1 score, the harmonic mean of precision and recall, providing balance between the two. Confusion matrix, a table that summarizes the performance of a classification model by showing true positive, true negative, false positive, and false negative. Importance, it helps identify strength and weakness of the model, guiding further improvements. Ensure the model meets the desired performance criteria before deployment. Classification process. Hold on. Then number 6 of the classification process. This is the final stage that involves integrating the trained and validated classification model into a production environment where it can be used for real-time predictions. The steps, we have modern integration, embedded the model into existing applications or system to enable automated classification of new data. Then we have monitoring and maintenance. Continuation monitor the model's performance in the production environment, tracking metrics to ensure it remains effective over time, especially at a new data pattern, especially as new data pattern emerge. Modern updates periodically retrain the model with new data to maintain accuracy and relevance. This may involve re-evaluating features, feature selecting and tuning consideration. Ensure the deployment process adheres to best practice for security and data privacy. Provide user training and documentation to facilitate effective use of the model. Classification algorithm. Ebenezer, are you there to take us through the classification of algorithms?
Yes, I'm present.
Okay, you can.
Okay, good morning, class. Good morning, Say. So I'll take you through the last segment of our presentation. First on classification algorithms. So first of all, we have the purpose. The first classification algorithm is the decision trees. So these are just models that split data into subsets based on the feature values. So the purpose of decision trees is they're used for both classification and regression tasks. So decision trees are split. Decision trees split the data into subsets based on the value of input values, creating a tree-like model of decisions and their possible consequences. So the advantages of a decision tree model is it's easy to interpret and visualize, and it also handles both categorical and numerical data as well. And then a disadvantage would be it's prone to overfitting, especially with deep trees. And then the second one will be random forest. So the purpose of a random forest algorithm is used to classify both it's used for classification and regression tasks. So an ensemble method that builds multiple regression trees and merges with their result to improve accuracy and control overfitting. An advantage of a random forest would be robust against overfitting, handles large data sets well, and also provides feature importance scores. And a disadvantage would be it's less interpretable than individual decision trees and can be computationally intensive. The next algorithm is the support vector machines. So this primarily used for classification tasks, especially in high dimensional spaces. So an SVM finds the hyperplane that best separates different classes in feature space, and it can also be used. It can use kernel functions to handle nonlinear classification. So an advantage of an SVM would be it's effective in high dimensional spaces and also works well with the mission. And then the fourth algorithm is the naive Bayes. So it's commonly used for text classification, for example, and it's a probabilistic classifier based on the Bayes theorem, assuming that the features are independent and given It calculates the probability of a class and selects the one with mentioned.
I think we are breaking. Yeah, breaking. Please go ahead. Hello, dear.
And
I think since we are a group, can somebody take over? I think we have lost here.
Hello, good morning.
All right, yes, go ahead.
It's Yvonne. I'm going to take over from Ebenezer.
Okay.
She was now on the classification algorithms. So the third one, support vector machines. So their purpose is primarily used for classification tasks, especially in high dimensional spaces. The description, SVM finds a hyperlen that best separates different classes in the feature space. It can use kernel functions to handle nonlinear classification problems. Its advantages are effective in high dimensional spaces, works well with clear margin of separation. And then its disadvantage can be used effective on very large data sets, sensitive to parameter tuning. Then the fourth classification algorithm is naive Bayes. Its purpose is commonly used for text classification, e.g., for example, spam detection. It's a probabilistic classifier based on Bayes' theorem. Assuming that the features are independent given the class label, it calculates the probability of each class, selects one with highest probability. Its advantage is simple and fast, performs well with large data sets, effective for text classification. And then its disadvantage is the independence assumption may not hold in real-world data. Then the next classification algorithm is k-nearest neighbors. Its purpose is used for classification and regression tasks. KNN classifies a data point based on the majority class among its k-nearest neighbors in the feature space. The distance metric, for example, Euclidean, is used to determine the nearest neighbor. The advantage, simple and intuitive, no training phase, effective with small data sets. Its disadvantage is computational intensive during prediction, sensitive to the trace of K and distance metric. And then we have logistic regression. Its purpose is to use for binary classification tasks. Logistic regression models the probability of binary outcome based on one or more predictor variables. It uses the logistic function to constrain the output between 0 and 1. Its advantages, easy to implement and interpret, provides probabilities for class membership. Its disadvantages is assumes a linear relationship between the input features and log odds of the outcome, not suitable for complex relationships. And then the next one is neural networks. It's used for complex classification tasks, including image and speech recognition. Neural networks consist of layers of interconnected nodes, neurons that learn to represent data through training. There's deep learning, a subset of neural networks involves multiple hidden layers. Its advantage is capable for capturing complex patterns and relationships in data is highly flexible. Then its disadvantages, it requires large amounts of data and computational resources can be difficult to interpret. Then we have the gradient boosting machines. It's used for classification and regression tasks. It's an ensemble method that builds models sequentially, where each one model corrects errors made by previous models. It commonly implements include XGBoost and GBM. Its advantages is high predictive accuracy, handles missing values well, robust against overfitting with proper tuning, and then its disadvantages can be more complex and harder to tune than simple models. And then we have the evaluation metrics for classification. So the accuracy, its definition is proportional correctly classified instances to total numbers of instances. This formula for accuracy is true positive plus true negative divided by true positive plus true negative plus false positive and plus false negative. This interpretation has high accuracy scores indicates that the model is making correct predictions. However, accuracy can be misleading. Then there's the precision. This one, the proportion of correctly classified positive instances out of all the instances predicted as positive. The formula, true positive divided by true positive plus false positive. Its interpretation, high precision means that the model is making few false positive predictions. And then we have the recall. The proportion of correctly classified positive instances out of all the actual positive instances. The formula of recall is true positive divided by true positive plus false negative. The interpretation, high recall means the model is capturing most of the positive instances. Then we have the F1 score, the harmonic meaning of precision and recall. The formula for F1 score is 2 times precision times recall divided by precision plus recall. A high F1 score indicates a good balance between precision and recall. Then we have the confusion matrix, a table that summarizes the performance of classification model. So the elements are true positive. This one correctly predicted positive instances. And then we have the true negative, correctly predicted the negative instances. And then we have the false positive, incorrectly predicted positive instances. Then we have the false negative, incorrectly predicted the negative instances. And then we have the ROC curve and AUC. The ROC curve is a plot that shows the true positive rate against the false positive rate. AUC is area under the curve, a metric that measures the overall performance of a classification model across different thresholds. A high AUC indicates better performance. And then we have the challenges of web mining. The first one is data quality. There's the noise and inconsistency. Noise of inconsistent data can lead to inaccurate classification results. Then there's also the issue of missing values. Handling missing data can be challenging as it can affect the model performance. Then we have class imbalance, which is keyword distribution. When one class has significant more instances than the others, it can bias the model towards the majority class. Underfitting, overfitting, imbalance can lead to underfitting, poor performance on the majority class, or overfitting, poor performance on the minority class. Then there is the challenge of feature engineering. Selecting relevant features, identifying the most informative features is crucial for accurate classification. Then creating new features. Features engineering can improve model performance, but requires domain knowledge and experimentation. And then there's the model complexity. which is overfitting. Complex models can overfit the training data, leading to poor generalization performance on new data. Then there's also underfitting. Simple models may not capture the underlying patterns in the data. And then there's also the challenge of computational cost, resource requirements. Some classification algorithms, especially the complex ones, like deep neural networks, can be computationally expensive. And then interpretability. Understanding the models, interpreting the decision-making process of complex models can be challenging, especially for black box models. And then the other challenge is domain knowledge. Expert understanding. Effective classification often requires domain knowledge to understand the underlying relationships and patterns in the data. Then there's the evolving data distribution. Models may need to be updated regularly to adapt to changes in data distribution trends. And then we move on to the next slide, which is future trends in classification. Is the explainable AI. Its importance as classification models, particularly complex ones like deep learning networks, become more prevalent. The need for interpretability is growing. Stakeholders want to understand how decisions are made. And then the trend development of new methods and tools that provide insights into model decisions, making processes, making it easier to explain results to non-technical users and ensuring compliance and regulations. Then the next trend is automated machine learning. Automating the process of selecting models, turning hyperparameters and performing feature engineering can democratize access to machine learning. There's the increased adoption of automated machine learning tools that simplify the classification process and enable non-experts to build and deploy models effectively. Then there's the trend of deep learning advancement. Deep learning continues to push the boundaries of classification performance, especially in areas like image and voice recognition. Ongoing research into novel architectures, e.g. transformers and techniques to improve efficiency, reduce training time, enhance performance in classification tasks. Then the next trend is transfer learning. Transfer learning allows models trained on one task to be applied to a different but related task, reducing the amount of data and time needed for training. The trend is increased use of pre-trained models and fine-tuning techniques in various domains, enabling faster and more effective classification solutions. Then there's federated learning. With rising concerns about data privacy, federated learning allows models training across decentralized devices without sharing raw data. So there's a growing adoption of federated learning approaches that enable classification models to learn from data on user devices while maintaining their privacy. And then the next future trend is bias mitigation fairness. As awareness of algorithms bias increases, there's pressing need to create fair and unbiased classification models. Development of techniques and frameworks detecting, measuring, and mitigating bias in classification models ensures equitable outcomes. And then the next trend is multimodal classification. It's important in the real world that often comes from multiple sources, formats, text, images, and audio. The increased focus in multimodal classification techniques that integrates and analyzes data from various modalities to improve accuracy and robustness. Then the next trend is edge computing for real-time classification. The demand for real-time processing applications like Internet of Things is growing. The development of lightweight classification models that can run on edge devices, allowing faster decision-making and reducing latency and bandwidth usage. Then we have integration and natural language processing. Text data is ambiguous and integrating classifications. with NLP capabilities can enhance understanding and processes of unstructured data. Increase the use of NLP techniques for text classification tasks and including sentiments and topic modeling and documented categorization. Then the other future trends are ensemble learning techniques. Importance of combined multiple models can lead to better performance than individual models. The growing interest in ensemble methods that leverage the strengths of various classifiers to improve accuracy and robustness and predictions. Then we also have the graph-based classification. Many data structures can be represented as graphs, e.g. social networks, molecular structures. Increased exploration of graph-based classification techniques that utilize the relationships between data points for more insightful classifications. Then the next one is real-time and streaming data classification. With the proliferation of real-time data sources, there's need for classification algorithms that can handle streaming data. Development of algorithms especially designed for real-time classification, enabling application in fraud detection, monitoring, and immediate decision. Then our conclusion. Classification is a fundamental technique in web mining analytics that involves categorizing data into predefined classes or categories. It plays a crucial role in extracting value insights from web data, enabling organizations to make informed decisions and improve their operations. By effectively applying classification techniques in addressing the associated challenges, organizations can gain valuable insights from their web data, improve decision-making, and enhance the overall performance. And then now we move on to our next presenter, who's going to take us through the code.
Maybe before you proceed, I don't know if I'm the only one who missed it. Maybe you might want to revisit the challenges that are associated with the classification in web mining. Maybe if you could revisit the page, okay. I think I missed that one. It's in order. You can proceed.
Now we can proceed. Okay.
Yeah.
And then we move on to the code.
Okay, thank you, Yvonne. Tapio, can you please beam the customer chain code presentation? Hello, Tapio, can you hear me?
Yes, I can hear you.
Can you please beam the customer chain code presentation?
Okay. Can you see it now?
Not yet, it's coming. Okay. So, all right. So, our task here was to build a classification model to predict whether a customer will churn or not. So we had we were working with our data set, the customer churn, and from the presentation we were given I think about 8 columns that we're working with. That is the customer ID, the tenure, monthly charge, total charge, contract type, internet service, payment method, and the churn. Right. So the first task, which is task number 1, was to explore the data and the pre-processing and data pre-processing. So we imported our libraries. Just hold. We imported our libraries, that is the pandas and the NumPy for data manipulation, Then we imported the matplotlib and the seaborn for visualizations. So the firstly, we loaded our data, which is, I think line number, I don't know, where it says load the data set. We loaded our data set. Then we had to display the first few rows. I think there'll be about five rows will be shown firstly. Then we checked for missing data, and we then checked for unique values, and we handled the unique values. Maybe Tapio, you can please go down where we show the results. Okay, so just hold, let me go to my code. So from the result there, we can see that we are displaying our first few rows, which will be 5 starting from index 0. So we are displaying our customer data, that is for all the columns that we have up to the chain. Then we checked for missing values in each column, and from what I'm seeing here, there were no missing values. We then checked for data types, that is for customer ID, it was an object. Then for tenure, it was an int, and the internet service, the contract, the total charges and the chain were objects. Then the monthly charges was a float data type, right? Then we then checked if we have categorical variables, and in this case we had the chain, which had a no and a yes variables. Then after that, just hold. Then after that, we after checking for our categorical variables, which is the chain with the yes and the no, we then handled. We had to change the chain column to be a numerical variable. So that is we had to change it to a 1 and a 0. Then after, we had to also convert other categorical variables. For example, we had the internet service, the contract, the payment method, using one-hot encoding, right? Using the true or false variables. Then after that, we had to check if we have any remaining non-numeric columns. And then we did our correlation matrix and our box plot. So we had the heat map, the correlation heat map. So our heat map, the color blue, it represents the negative. Then the color red, which represents the positive. So this just like basically indicates the strength and direction of the correlation. So the blue one, which is the negative, it says that if one variable increases, the other decreases, and the red one says if one variable increases, it also increases with the correlation. So maybe just to give an overall of the heat map, I think it suggests that customers who have been with the service provider longer have a higher total charges and pay with the credit card automatically, right? Then Tapio, if you can go down to the box, to the last box plot, the last one with the change versus the total charges. Yes. So this box plot, it says that the customers who churned have higher total charges and are more spread out, with more spread out distribution of charges. So that's what is saying on the last box plot. Then we go to task number 2. Task number 2, we're supposed to build and evaluate the classification model. So we did the same thing. We imported our libraries, we loaded our data set, Then we did our initial exploration. That is the number of rows, number of columns in the data frame, the first rows. Then we checked for missing values, verified the data types for each column, and exposed the unique values in each categorical variable. Then after that, just hold. So we then handled our missing data, and I think now we then checked for if we have any missing values, and before dropping, we had to check the shape of our data set, and in this case it was just hold. Let me go. Yeah, in this case, it was we had it was a 7043 with and cove. Okay, and then after we had to train our data set. Right, so the request from the presentation was to split our data set into like 80 the training data, then 20 the test data. So that's what we did there. That's what we did. We trained our data. Then we splitted our data rather than not trained our data. We splitted our data with using the random state of 42. I think it's called the random state of 42, if I'm not mistaken. So after checking our shape before dropping the missing values, we then had to drop again the missing values. So after we dropped the missing values, we had to verify the shape. So when we were verifying the shape, we then noted that the shape now had 0.12. So which means we had insufficient data, and we couldn't train. So there was insufficient data for us to train or to test after we had cleaned all our data. So we could not do the confusion matrix, the accuracy score, because we had no data to train or to test. Right. Then we can go to task number 3. Task number 3 is almost the same as task number 2, where we imported our libraries, we loaded our data set, we do our exploratory data analysis, that is displaying the first rows, checking for missing data, checking the data types, and handling missing values. And then we had to check again the shape after handling missing values. Then we had to convert the chain to a numerical variable. And we also had to convert our categorical variables, that is the contract, the payment method, using one-hot encoding. That is we had to, we were using the true or false values. Then after that, we had to check if all columns were numerical. Then we had to check for missing values after conversion of them, of our variables after conversion of our categorical variables to true and false. Then after that, we checked the shape of the data frame. Then we dropped any missing values, and then we had to check again the shape, just like we did on task number 2. Then after that, we had to ensure that we still have data before splitting. Right, and in this case, we noted that we still had no data. So this basically means that the data set that we used had insufficient data. Maybe the number of columns we were using, because after everything that we did, we noted that we still had no data to even train or to even test, and there was nowhere else to go. And then, yeah, I think that was all for it. Thank you.
Thank you so much, Group 1. I'm very impressed, especially the first part of your presentation. You did very, very well. Thank you for that. However, your practical now, where you were just supposed to consult with me. What you need, you don't necessarily need to use that data set that you had. There are a lot of data sets on the internet. So you were supposed to give us any other examples as long as it followed the guide for the questions and everything. So I'm requesting you that you work with an already existing data set. You download it. There are so many. So you change your example to something that already has a data set. But you were supposed to generate one. But since you couldn't, you can always grab one. There is a website. I think check on the public chat, cargo.com. There are a lot of examples there. Sorry, it's cargo.com. But there are so many other data sets that we are freely available on the internet, which are with examples on how to carry out classification tasks. Okay, so can I have this by let me give you on Tuesday or Wednesday? Make sure you then do send your practical together with the presentations on Wednesday. But otherwise, thanks so much. That was what you want to.
Just a reaction, Doc. And when you revise or you revisit this exercise, most split coding, code in one cell. It's very difficult to debug. You break yourself to know I'm now converting my category of variables. I'm doing this task line by line, so that when you debug, it will be very easy. And always a code, yes, same one cell.
And not only that, you remember you told us about the classification process. The first stage, code second stage, code third stage, code until the sixth. We want to see that. Thank you so much, Group 1. That was very, very good. Can we have the next group, please?
Good morning, Doctor.
Morning. Yes, I think let me end this session so that in terms of the file size, we will reduce in terms of gig because you want to watch this video. So let me just end the lecture session, then remain online. You automatically be joined. Okay.